Hey, this is Stephen Ament. Welcome to my Exorcism.io series. In this episode, I'll be working through the luhn exercise. So the luhn exercise has us determine whether or not a given number is valid according to the luhn algorithm. A valid credit card number is probably the most common check. It's also a way of testing Canadian social insurance numbers. And so the way that this algorithm works is first we need to check the length of a string. Strings of length 1 or fewer numbers are not valid. Spaces are allowed, but they have to be stripped before we do the rest of the check. And no other non-digit characters are allowed. Okay, so the way that we determine whether or not the number, once we've stripped out the spaces, is valid or not, is starting from the right, we look at every other number and we double them. If the number is greater than 9, we subtract 9 to keep a single digit value for our number. Then we'll sum the digits, and if the sum is evenly divisible by 10, then the number is valid according to the luhn algorithm. Okay, let's jump right in. Let's open up our testing pane and execute our test, and it will fail because we have not created the luhn.rb file yet. So let's do that. Now it fails because we haven't defined our class. And then this is going to fail because it's expecting, we're looking for a class method valid A self. All right, so let's define that valid A, which this also will fail because it is expecting an argument, which I struggle with what to call this. I think we can call it, we can't assume it's a credit card number. It could also be a social insurance number. Let's call it luhn number. It's a little tricky because we're giving it a string. We're not giving it an integer or other number. And so the naming can be a little bit deceptive here. So this is something which we want to be, naming is tricky. We want to be a little bit careful with what we're doing. But for now, we're going to go with that. Now you'll notice that the test passed. We haven't implemented anything. Why did the test pass? Well, because in this case, this is a method that's going to return a Boolean-ish value. That's what we expect whenever you have a method in Ruby that ends with a question mark. You're expecting it to be truthy or falsy. Well, when we don't return anything, when we don't do any activity here, our method is going to return nil. Well, nil is falsy. So this actually works. And in fact, it's going to work here for one more. And this is the first case in which it's going to fail. Because we actually have a value here. So what can we do? There's a couple ways we could do this. We can return false if the length of our input is less than or equal to 1, because that was our first condition, and otherwise return true. Okay, what's going on here? If we actually have to say if. There we go. Clearly that's not enough. Once we get a couple more down here, because, well, this one's going to work. This one is going to force us to actually do our implementation, drive our implementation out somewhat, and that's fine. So we have 2 social insurance numbers. One is valid. One is invalid. So we have the 2 cases that we need to actually drive this out. And so like we always do, I'm just going to brute force this in place. I think ultimately, once we refactor this, the code is going to look pretty different from what we come up with here. But our first objective is just to get this thing working, right? red, green, refactor. And what red, green, refactor, that mantra means, red means that we have failing tests first. Then green is we make those tests pass, and then we refactor it to something more maintainable. And that's what I mean by good code, is something that's going to be more maintainable. And then a quick note about how we're doing this here. If we were doing real world TDD, we would not have all these tests pre-written, or I wouldn't do it that way. I'm gonna write one test that fails, and I'm gonna make it pass, and then I'm gonna write the next test, and then I'm gonna make it pass. And by having these skips in here and removing the skips one at a time, we're sort of imitating that. Really, if I were implementing it myself, this is what my test would look like right now. I wouldn't have all these other tests written. Some people like to write a bunch of tests and then just kind of work through them. I prefer to do it in real time as I go. All right, so here we are with a failing test that's going to force us to build out this functionality. So what do we do in this case? So we need to get these digits that were being passed into a form that we can do the calculation. So what I see right away is there are spaces here that we need to remove. So we can do that on the string itself. Let's go ahead and remove those with a G sub, I think, for now. We're going to replace every string character just with nothing. And then once we have that, we want to split this into individual characters to give us an array, because an array is going to be easier to work with. Now, what we need to do is we need to start working from right to left, and every other digit, remember we have to double it, subtracting 9 if it's greater than 9. Then we want the sum, and then we're going to check to see if that sum is evenly divisible by 10. So we now have an array of these numbers, and we need to work from right to left. So that tells me we need to reverse. So we could map over these, but how do we know which, if we're looking at the first digit or the second digit as we're going, if we just map? Well, we need more information than that. We need the index. It would be great if we could map with index, but we can't do that. But what we can do is each with index, and if we don't give that a block, it's going to give us an enumeration, which in that case we can map over an enumeration. And so those two things combined, each with index and map, it's going to give us our digit, and it's going to give us our index. Wow, that's quite a long line there. We're going to clean this up a lot before we're done, so don't worry too much about it. Okay, so we have our digit here, but it's a char. It's a string. So we want it to be an integer. So let's go ahead and get an integer. And then we want to double it. Well, hang on. If our index, so let's see, which one do we want? We start with 0, and we want to double 1, 3, 5. So we want to double the odd digits, because we're going from right to left. So we want to take our digit, we want to double it, times equal 2, and then we want to subtract 9 minus equals 9 if our digit is itself greater than 9. And then in any case, we want to return digit. So remember, what map does is it for each element in your array or each element in your enumeration, whatever you return from this block, it's going to replace the element with whatever you return. And so we're going to have a new array with a new set of elements. But for the odd digits, we're going to double them, doing this this extra little work here for if it's going to be more than a single digit number, or we're just returning what we have. And then once we have that new array with those things doubled, we need to get the sum of all of those elements. And we're going to take that sum and test whether or not it's evenly divisible by 10. So how do we test whether a number is evenly divisible by something else? Well, to be evenly divisible by means that if we divide it by 10, the remainder will be 0. So the modulus operator gives us that. So the sum modulo 10 will be equal to 0. And I think this is our test. I think this is going to make this pass. Yeah, it did. So it's pretty ugly code right now, but it's that's okay. We're not going to worry about that yet. It's okay that it's ugly. It's okay that it's not beautiful code, because we're going to fix that. Trust the process. Just make it pass. Okay, so this failed because we have a non-digit character here, and we're not checking for those yet. So in addition to this check for the length, we want to check for non-digit characters. So we can just do a simple match check like this, but this is going to test too much because spaces are okay. So before we do that, we need to go ahead here and duplicate our G sub. And that's okay because we're going to clean this up quite a bit. So I don't mind doing this explicitly right now because I already know ahead of time that, something is radically going to change by the time we're done. So let's just keep stepping through. This is going to pass. Our next test, this is going to pass because these dashes make this an invalid number. These financial symbols here make this an invalid number, so it's going to pass. I'm a little curious about what this one is going to do. So this is one character with a space. This is going to fail right now because we actually need to do this G sub as well on the previous. So you can kind of see this replacing strings is something we're going to need to do on our input before we do anything else. I'm not going to worry about all that duplication yet because, like I said, we're going to clean that up quite a bit. And I think we might be done, but I'm not going to worry about it, about all that duplication yet because we're going to clean this up quite a bit. All right, so we have our first set of working code here. It's ugly, but it actually does the work. And I, in the spirit in which I've been doing these things, I'm going to go ahead and submit this. As my first solution. And this code has a long way to go before we're done. I think what we end up with as sort of our final code here, once we've refactored this, it's going to be radically different from what we have here. And I think this might end up being the most radically different refactoring that we've had to date, but we'll see. We'll see what you think. But for now, let's pause here, and we will come back in a follow-up episode to refactor this code.